Welcome friends. In our previous lectures we have seen the different numericals on T-beam, how to analyze the T-beam. Okay, but till now we have completed only two cases, case number 1 and case number 2. Okay, so in today's lecture we are going to cover the numericals based on the case number 3, how to find out the moment of resistance of a T-beam which belongs to case number 3. Okay. So I will read the numerical first and then we will start with the solution. Okay. So find out the moment of resistance mu of T-beam with the following data. See, the data is given: Bf is equal to 1250, Df is equal to 100, Bw is equal to 250, D is equal to 650, AST is equal to 2800, Fy 415 and FCK 20 Newton per ampere square. Okay. All the relevant information is given. We just have to find out the mu value. Okay. So our first step is to identify the case. First step to solve this numerical is to identify from which case it belongs. Okay. Now to find out, first we will check whether it is in case 1. If it is in case 1, then it is okay. We will proceed with the case 1. But if it is not in case 1, then it may be from case 2 or 3. Then we will assume that it is from case 2 and we will solve the numerical. But if our value of xu is again matching with our assumption from case 2, then okay. Again, if it is not matching, then we have to proceed for the case number 3 and then we have to solve. If it is not in case 1 and case 2, definitely it will be from case number 3. Okay, no need to check. So let us start with the solution. So first find out the value of ASF, that is reinforcement AST required for compression to be within the flange. If the actual given value of AST is greater than ASF, then it is not in case 1. If given value of AST is less than ASF, then it is from case 1. Okay. So let us start. So first find out ASF value, that is 0.36 FCK TF divided by 0.87 Fy. Okay. Now 0.36 FCK 20, Bf is 1250, Df is 100 and whole divided by 0.87 into 4.5. Okay. So if we calculate this, you will get 2492. What does it shows? Given value of reinforcement is 2800. So given value of reinforcement is more than ASF. It means XU value is more than DF. Okay. ASF is more than ASF is less than ASF. Given value of AST is greater than DF. So XU value is greater than DF. XU value is greater than DF. So it will not be in case 1. It may be in case number 2 or 3. Now assuming case number 2. Assuming case 2. Assuming case 2. Now what is in case 2? X value is greater than DF. Yes. And DF is less than 0.43x. DF is less than 0.43x. This is our case 2. Now we will find out actual value of XU and we will check whether it is correct or not. How do we find out actual value of XU? See, it may be any problem related to the single reinforced section. Suppose you want to ask if they ask to find out the value of XU. This is a general equation, that is compression equal to tension. From this you will get actual value of XU. It may be T-beam, it may be single reinforced rectangle. Okay. So what is compression? Compression in wave plus compression in flange. Okay. So compression in wave I will calculate first. That is 0.36 FCK Bw into XU plus compression in wave is over. Now compression is flange. 0.446 FCK into bracket BF minus BW into DF is equal to tension 0.87 FY into AC. Just substitute all the values. 0.36 FCK is 20, BW is 250 into XU plus 0.446 FCK is 20, the BF is 1250 minus 230 into 100 87,415,280. Substitute all the values. Now if you calculate the value of XU from this equation, you will get XU is equal to 66.07. So now what it shows? It shows that our assumption is wrong. That XU value is greater than DF, but actual value calculated from this is 66.07. It means our assumption is wrong. So it is not in case 1, it is not also in case 2. So now we will assume that it is in case 3. Okay. So now what is our case 3? It is XU greater than DF, okay, but DF is greater than 0.43 XU. DF is greater than 0.43 XU. Now, see, we will find out the XU value again. Compression equal to tension. Now, what is compression again? CUF, CUW. But here is one more term. Here one term is introduced for case number 3. That is YF. So first, let us calculate what is YF. So YF is again 0.15 XU plus 0.65 DF. Okay. Now compression is equal to tension. Now compression in weight plus compression in flange. So compression in weight 0.36 FCK BW into XU plus DF 0.446 FCK BW, not BW, BF minus BW into YF. What is YF? YF is 15 XU plus 0.65 DF is equal to, now this is total compression, is equal to tension 0.87 FY into AC. Okay. Now this entire term, only a known value is XU. All other values are known to us. All other values are known to us. Now FCK is known, BW is known, FCK, BF minus BW, DF, FY, AST. Everything is known to us. Only XU is unknown. Now if you calculate the XU value from this, you will get XU as 104, which I have calculated 104.19. Now we will check whether this XU value satisfies our assumption. This XU is 104.19. XU is 104.19. It means XU is greater than DF. XU is greater than DF. Okay. Now we have to check what is 0.43 XU. 0.43 XU. So 0.43 multiplied by 104.1. This value should be less than DF. So now 0.43 multiplied by 104, it will be close to 0.43 only, or otherwise it is 45 mm something. But value of DF is 100, so definitely this value 0.43 XU is less than DF. If you calculate this, you will get this value as well. Yes, it is 44.80. 44.80. It means it is less than DF. Now, see, our assumption number 3 that is df is xu is greater than df and df is greater than 0.43. Xu means 44.80. Alright. Okay. Now we'll calculate the mu because we are aware we have come with the actual case of the given problem. Okay. Now we'll find out the mu value. So before that, first we have to find out the YF value. YF is 0.15 XU plus 0.65 dm. Okay. So 0.15 XU is 104.19 plus 0.65 dm is 100. If we calculate this, it is 80.63. Okay. Now we calculate index. So first compare the value of XU with XU max. So it is XU max is 0.48 d and its value is 311. So definitely it is XU max is greater than XU, so it is under input section. So we can calculate the moment of resistance as mu into mu is equal to compression or tension into lever arm. If you use the compression into lever arm, you have to put the value of x as the actual x, not XU max. Okay. So compression into lever arm, mu is equal to compression into lever arm. Okay. So mu is equal to. So first moment due to wave and then we will take moment due to flange. So moment due to wave 0.36 FCK, then VW into XU into bracket V minus 0.42 XU. Okay. Then 0.446 FCK, then VF minus VW into YF into D minus YF divided by 2. Okay. So now substitute all the values available. FCK is 20, PW is 250, XU we have 104.19, D is, what is D? D is 650. YF is 80.63. Yes, first we will finish this row, this line 0.42, XU again 104.19 plus now 0.446, FCK is 20, BF is 1250 minus VW 250, YF is 80.63, D is 650, 80.63 divided by 2. Okay. If you calculate this, you will get value of mu, that is 552.27 kilonewton meter. Okay. So how we have proceed for this example? First we have checked whether it is in case number 1. Then we have assumed that it is in case number 2 and we have cross-checked the value of XU with our assumption. Then we have concluded that it is not in case number 2 also. So then we have assumed that it is in case number 3 and again we have calculated the XU value. But for this we have to introduce one term, that is YF, which is the characteristic of case number 3. Okay. And we have calculated the value of XU and we have received the value of XU is equal to 104.19. And if you compare, if you check the actual XU value with our assumption that it is in case number 3, which is correct. Okay. Then we have calculated the MU value as per the case number 3, that is compression into lever arm. So lever arm with respect to their location of forces. So D minus 0.4842x is the lever arm for compression in weight, and D minus 0.52 it is lever arm for compression in flange. So this is the equation which we have generated in lecture number 1 of this T and L beam. So lecture number 2 of T and L beam. So this entire equation we have developed. Okay. The same equation I have used here. Just substituted all the values and we have calculated the value of mu as 552.27 kilonewton per meter. Okay. So that's it. We have completed case number 1, 2 and 3. How to find out the mu. Okay. In the lecture notes I have given all these numericals. You can go through it. If you are having any doubt regarding T and L beam, you can ask me. Okay. Thank you.